and today we're going to be showing the melting point of 3 different materials, which is copper, steel, and aluminum. And as you can see, they're kind of about the same thickness. And following showing the melting point, we're going to show when each material begins to plastically deform. Okay, so the first one we're going to do is steel, and you can see it's relatively thin. And we're going to use an oxyacetylene torch to melt it, but since none of us know how to use it, my husband's going to do it for us so we don't burn the place down. So as you can see, the metal deformed and dripped some. Okay, so the next one we're going to do is copper, and it has a melting point a lot lower than steel, so this is going to be pretty quick. Okay, then last one is aluminum, and it should be the quickest of them all. Okay, so now we're going to show when each metal plastically deforms, and the first one we're going to do is steel. So obviously steel is very strong, and I cannot bend it with my hands. So we're going to use this 20-ton shot press to bend the metal. It's going to make it look very easy, but obviously it's not because it's steel. Okay, so we took it off the press to show how much it bent with that little bit of force from a 20-ton press. So as you can see, it bent pretty good. Okay, so now we're going to do copper, and copper is a lot more malleable than steel is, so it's going to take a lot less pressure to make it bend. So its yield strength is a lot less than that of steel, and so it's nothing for me to bend it around. Okay, so the last one is aluminum, and it's going to be easier to bend than the steel, but a little bit harder than that of the copper. I can bend it with my hands, but it's going to take a lot more strength. And it's kind of sharp around the edges, so it's going to be a little bit harder for me to bend. So as you can see, it took a lot more force for my hands to bend it, so it had a lot higher yield strength than that of the copper, but less than that of the steel. Okay, so the last thing we're going to do is show how increasing the temperature of each metal changes the plastic deformation point of each metal. So the first one we're going to do is steel, and again, my husband's going to heat up the metal for me, and I'm going to take these pliers because it's hot and bend the metal with my hand, whereas before with steel, I couldn't bend it with my hand. Okay, so the next one's going to be aluminum, and it's going to take not near as much as the time that it did with the steel to be able to bend it.
Hi, I'm Joe, and as shown in the demonstration, I'm going to show why steel was the toughest material. It had the highest melting point, and it was the hardest to bend. And that's mostly because steel is an alloy made up mostly of iron with an interstitial carbon atoms within. Iron, for the most part, has a face-centered cubic structure, which looks about like this, with the red being iron. And then as we add carbon atoms, the carbon atoms are going to come between the iron atoms, and that's going to cause the material to be a lot more dense, and it's going to make it harder for the iron atoms to move around, which is going to increase the yield strength of the material, and it's going to increase the melting temperature. It's going to make it a lot harder to bend, a lot more brittle, and it's going to take away from the ductility of the material.
Hi, I'm Hyeon, and I'm here to talk about aluminum and copper. So they both have FCC structures, and they are both very ductile and not brittle because of their weak bonds, so that makes it have a lower yield strength. And aluminum is weaker than copper because it has weaker bonds, making it more ductile and have a lower melting point.